All right, let's just state the obvious. AI is everywhere these days, right? You literally can't escape it. It's on the news, it's in all of our apps, it's completely changing how businesses work. The buzz is real and it's loud. But let's be honest, with all that talk comes a ton of confusion. You hear all these terms being thrown around. AI, machine learning, deep learning. Are they all the same thing? Where does one end and the other begin? And what's the deal with this new generative AI that's taken over everything? It can feel like you're trying to untangle a giant knot of tech jargon. Well, that's exactly what we're going to do right now. We are going to untangle that knot. In this explainer, we'll break it all down, piece by piece. We'll demystify these terms, show you how they all connect, and even look at how this technology is being used to build super secure private AI systems, a concept people are starting to call sovereign intelligence. So here's our roadmap. We'll kick things off with a big picture, artificial intelligence. Then we'll zoom in on machine learning, and then go even deeper with deep learning. From there, we'll get into the generative AI boom, check out how it's being used in the real world, and finally, we'll take a little peek into the not-so-distant future. All right, let's start at the beginning. Let's talk about the original, foundational dream itself, artificial intelligence. I want you to think of AI as the giant umbrella that covers everything else we're going to talk about. It's the grand vision, the whole field dedicated to getting computers to do things that, until now, have required human smarts. We're talking learning, solving problems, reasoning, the whole shebang. It's the entire universe we're exploring. And wow, has our approach to this changed over the years. Back in the 80s, it was all about so-called expert systems. The idea was to painstakingly program a machine with millions of if-then rules for every single possibility. As you can imagine, it was incredibly brittle. But then, around the 2010s, we flipped the script entirely. Instead of feeding machines rules, we started feeding them data and letting them figure out the rules for themselves. That one shift, that's what made everything we see today possible. And that whole idea of a machine learning from data, well, it has a name, and it brings us to our next layer in this puzzle, machine learning. So this is the absolute key to understanding machine learning, or ML. As a developer, you stop being a programmer who writes every single instruction. Instead, you become more like a teacher who provides the textbooks. You just feed the machine massive amounts of data and let it discover the patterns on its own. It's learning by example, not from a strict rulebook. Think about it like this. If I show you a simple pattern of shapes, your brain immediately tries to figure out what comes next, right? ML algorithms do exactly the same thing, just on a ridiculous scale with mountains of data. And the more examples they see, the better they get at predicting what's next. Or, just as importantly, spotting when something is wrong, when something doesn't fit the pattern. That's precisely how banks catch fraud, or how a cybersecurity system spots an intruder. Okay, so ML is powerful, but how do we get it to learn even more complex, abstract stuff? Well, that brings us to the real engine behind pretty much all of today's incredible AI breakthroughs, deep learning. So if machine learning is the overall strategy, you can think of deep learning as a specific souped-up tactic within that strategy. What makes it deep is its structure. It uses these complex, multi-layered neural networks, which are actually inspired by the way neurons are connected in our own brains. This layered structure allows it to learn way more intricate and abstract patterns from data than traditional ML ever could. This really is the perfect way to picture the whole relationship. It's like one of those Russian nesting dolls. The biggest doll on the outside is artificial intelligence, the whole field. You open it up, and inside you find machine learning, a specific way to do AI. Then you open that doll, and inside is the core, deep learning, a superpowered technique that has made modern AI a reality. And that powerful deep learning engine is exactly what brought us to the revolution we're all living through right now, the generative AI explosion. The technology at the heart of this wave is something called foundation models. We're talking about massive deep learning models that have been trained on an almost unimaginable amount of data, basically a giant slice of the internet. The cool part is they're not built for just one job. They're designed to be a a foundation that can then be adapted for a huge range of different things. A fantastic way to get your head around this, especially with large language models or LLMs, is to think of your phone's autocomplete, but on a cosmic scale. It's not just guessing the next word, it's using the patterns it learned from all that data to predict the most likely next sentence or the next paragraph, or even generate a brand new image from nothing. It's not just predicting, it's creative. And that ability to create, that's what changed everything. For years, AI and machine learning had a slow, steady adoption rate. But generative AI just blew the doors off. Suddenly, this powerful technology was accessible and genuinely useful to everyone overnight. The adoption curve didn't just bend upwards, it went absolutely vertical.
Okay, so that's the theory. But how does all this tech play out in the high-stakes world of a real business, where security and privacy are non-negotiable? Let's zoom in on a concrete case study from a company called Treecapital.
So, Treecapital builds what they call sovereign AI with their Anvin model. And the keyword there is sovereign. It's all about total control and privacy. See, with most public AI tools, you're sending your data to some third-party server. But Anvin is deployed directly inside a company's own private cloud. This is a total game changer because it means their most sensitive, proprietary data, their secret sauce, never leaves their secure environment.
Now, an out-of-the-box foundation model is a jack of all trades but a master of none. It knows a little about everything, but it doesn't know about your specific business. That's where the real magic happens. Tree Capital uses a process called fine-tuning to transform that generalist model into a world-class specialist. They train it on a company's internal documents, their data, their unique jargon, until it becomes a true expert in their domain.
And they do this with some incredibly precise techniques. For instance, they use methods like QLoRa to make the AI super efficient so it can run on smaller, less expensive hardware. But here's the most important part for reliability. They use something called Retrieval Augmented Generation, or RAG. It's a fancy name for a simple, brilliant idea. Before the AI gives an answer, it's forced to look up the facts in the company's own private knowledge base. This is absolutely crucial for stomping out those weird AI errors or hallucinations. And the business impact of this is just enormous. When you combine a fine-tuned specialist AI with this kind of efficiency, companies can see their operational costs drop by as much as 60%. That is how you translate all this abstract AI theory into tangible bottom-line value. So that's the state of play today. But in the world of AI, today's breakthrough is tomorrow's baseline. The pace is just relentless. So what's just around the corner? Well, by 2026, things are predicted to get even crazier. We're talking about teams of specialized AI agents collaborating with each other to solve problems, a true digital workforce. We'll see the rise of physical AI with world models that understand real-world physics to power sophisticated robots. And maybe the coolest for our daily lives, small, powerful models that can think and reason right on your phone or laptop, completely offline, with no internet needed. And all of this leads to a pretty profound final thought. We're watching AI evolve from something that just processes text and images on a screen to autonomous agents and intelligent robots that can actually interact with our world. We're seeing this incredible convergence of technologies, and it forces you to ask the big question. What happens when this powerful digital intelligence is no longer confined to our